My name is Kellen. Welcome to the course. It's time for us to focus on the sufficient condition for QCA or csQCA. First of all, we should be aware of what the logic of sufficiency is. A condition is sufficient for an outcome if whenever it is present across the cases, and the outcome is also present in these cases. There should not be a case that shows the condition but not the outcome. The sufficiency can be expressed as the condition X, the arrowed left to right, and then the outcome Y. We can read the sufficiency statement as if X then Y, or X implies Y, or X is a subset of Y. Usually, when we analyzing the sufficiency, we are analyzing the subset relations. It is also important to note that cases with not X are logically relevant for the statement of sufficiency of X because set relations are asymmetric. Alternatively said, if X is sufficient for Y, we cannot automatically conclude that not X implies not Y. The first way to demonstrate the test of sufficiency for QCA is using a data matrix. For instance, we have one QCA condition X and one QCA outcome Y. The value in these columns is 1, 0. 1 indicates the condition or the outcome is present, while 0 indicates the conditions or outcome is absent. There are 4 cases are logically possible: A, B, C, and D. When we have cases with X equals to 1 and Y equals to 1, like case A, and no cases with X equals to 1, but Y equals to 0, like case B, then we have the empirical evidence that is enough to confirm X is sufficient for Y. In addition, with the sufficiency length of X for Y, we cannot say anything about the sufficiency of not X for Y, like case C, or not X for not Y, like case D. We also can demonstrate the claim of sufficiency in a 2x2 table. And again, only cases with X is present and Y present are relevant, while cases with X present and Y is absent are avoided to have enough empirical support for the claim that X is sufficient for Y. One of the other useful ways to present sufficiency for QCA is Venn diagram. In Venn diagram, we have circles, and each circle is a set. We have the condition set X and the outcome set Y. If X is sufficient for Y, the circle for set X is fully contained in the circle for set Y. We can say X is a subset of Y in this case. We might notice that the area outside X but inside Y means X is absent and Y is present. And the area outside X and outside Y means both X and Y are absent. These two areas are not relevant for the claim of sufficiency of X for Y. The rectangle around the circles is the universal set. It is noted that X does not account for all cases that are the member of Y. Thus, there must be other subset of Y which represent for other sufficient conditions different than X. The smaller the Y are covered by X is, the smaller X empirical importance as a sufficient condition is. And this diagram does not display any area with cases that display X but not Y, as required by the logic of sufficiency. Now, it is easier to dive in an example of sufficiency analysis of csQCA. We have an example in which we are interested in the conditions for high-performance firms. In particular, based on the theory, we expect the three condition sets A that stand for firms investing in AI, D stand for firms investing in data, and B stand for firms investing in people, are sufficient for the outcome HB, high-performance firms. Each row is the observation from one specific firm. Each column has crisis values. 1 means a full member of the set, and 0 means the non-full member of the set. The first simple step, we may start by investigating which individual conditions A, D, B are sufficient for the outcome. Let's start with the condition A, firms investing in AI. Based on the logic of sufficiency, only those cases that contain the presence of the condition are relevant. For condition A, cases 1, 2, 4, and 5 are relevant, where A takes the value 1. We are supposed to find the cases where A takes the value 1 and the outcome HB also takes the value 1. If so, A is the sufficient condition for the outcome. Yet, we figure out that A is linked to the value of 0 in the outcome HB in case number 1. That is against of the sufficiency claim, and it is enough by itself to show that A investing in AI is not a sufficient condition for high-performance firms, regardless of what happens in other cases. We can do the examination for other single conditions. In the next step, we may ask if a combination of conditions is sufficient for the outcome. Based on some theories, we believe that firms investing in all three conditions, AI, data, and people at the same time, may have positive outcome. Then we add a new column we call A and D and B. That is a new condition, and it represents for the membership of all cases in the combined set of A, D, and B. The logical values in that column indicate whether the combination ADB is present in a given case with value 1 or not with value 0. And we find that the last case, data sky, takes the value of 1 in the combined set ADB as well as the value of 1 in the outcome HB. And no cases take the value of 1 in the combined set but the 0 value in the outcome. We have enough empirical support to confirm that the sufficiency claim of the combination of A, B, and D for the outcome high performance firms. Or we say the conjunctural condition ADB implies HB. We have made it through this chapter. As a final note, the logic of sufficiency for QCA, whenever the condition is present, the outcome is also present, and that condition is sufficient for the outcome. No cases should be displayed when the condition is present but the outcome is absent. And in the representation form Venn diagram, X is a subset of Y. I hope the course is useful for you. There are more relevant topics in this course. Let's learn more and see how you can apply set theoretic methods, such as QCA, in your work and social science research. Thank you.